All right, ladies and gentlemen. So today, we are looking at our functions again, but we're adding a new wrinkle, okay? In my lesson today, one standard that was targeted was using functions and their rules to notice patterns. I really hope my students would be able to understand functions that have rules with 2 operations in them, as opposed to just 1, which we had only done up to that point, and then be able to use tips, techniques, and strategies to be able to predict input and output from a rule, or given input and output, define what the rule is. What is different about this rule compared to other rules we have seen?
+2.
Times 2, then 1.
Ah, times 2, then 1, right? And the difference is 2 operations. Great. I love how you said operations, okay? So we have to do those 2 things now. We have to multiply, and then we're gonna add 1, all right? Gwen, can you tell me, if my input is 2, what am I going to do to find my output?
You're going to times it by 2, which is 4, and then you're going to add the 1, is 5.
And then 4 plus 1.
Am I right?
Gives me 5, and yes, you're absolutely right.
Oh, okay.
Thank you. Wonderful explanation. Okay, George. Mr. Mathis, will you explain the next one to me? I have an input.
Oh, it'll be 8 plus 1.
How'd you get the 8?
It's 2 times 4 is 8, plus 1 is 9.
And that gives us 9. Great. Okay. Everybody understand what's going on? Okay. They're just like the other ones, except now there's 2 things. We used to just multiply or just add or just subtract, but now we're shaking it up a little bit, okay? Let's look right here, okay? Now, I need the input. Once you get to the point where you're looking more at an output and trying to reverse engineer it to the input, it can become much trickier. So what am I gonna have to think about if I'm trying to find the input from the output?
The opposite.
I'm gonna do the opposite, okay? And when you say the opposite, you mean the opposite of what?
Of addition and of multiplication.
Ah, he said he's gonna do the opposite of this addition and multiplication. Now, Kevin, something I noticed is very interesting about what you said. You said the addition and then the multiplication, even though it says that first. Why would you say that?
Just going in order.
Just going in order. When I'm doing this, ladies and gentlemen, when I'm doing times 2, then plus 1, right? If I'm undoing something, what order do I go through? Do I go through the order I did it in? No, you start at the back and then you work your way to the front. And that's exactly what Kevin noticed. So the last thing that I did to whatever this number was to make it 21 was what? The last thing I did was add a 1. The last thing I did was add a 1. Oh, okay. So before I added that 1, it must have been 20. And now that I'm thinking of that it was from 20, that makes it a little easier to figure out what happened there, right? So who can explain to me what would you do from then? We know that 21 minus 1 is 20, so that means before we multiplied, we had a number that when we multiplied, it gave us 20.
10.
You think it'd be 10? Okay. Gwen says 10. Well, let's see. Kevin, you told us to use the what?
The opposite operation.
The opposite operation. And what's the opposite of this?
Division.
Division. So 20 divided by 2 does give me 10. Okay? And Gwen, that's what you guessed. Who can tell me how would I check that? How would I check to see if 10 is right? Let's go with Peter.
Subtract 10 from 21, and then look at where the plus 1 is. Make it a subtraction, and then do the opposite. Take the 1 out and just keep the 10.
So here's the one little thing, right? We got the 10 by starting with the output, right? So the 10 is what? The 10 is in the input. So when Kevin said to do the opposite, if I start with the output, I do the opposite. But if I'm starting from the input, I just do exactly what it says. So to check it, plug it in there, Peter, and what happened?
2 times 10
2 times 10
plus 1
plus 1. And what's 2
equals
times 10?
20,
And what's 20 plus 1?
21.
Is that a right answer?
Yes.
You are right, sir. Thank you very much. They did a good job of really analyzing and breaking down and looking at what they did, and then we would discuss the steps it would take to do it right. And I don't give that to them. You know, I might point them in a direction, but they're the one who walks there. Somebody else, please explain this one right here to me, okay? Please explain that one right there. Jarrell. Jarrell, I'm starting with 31 as an output. How do I find my input?
You subtract 1 from 30,
Okay.
then you divide 30 by 2.
And then 30. Let's go ahead and write it out that way. That goes in there 1 time. Leaves 1 left over. What do I do next?
Bring your 0 down.
Bring down my 0. And then what? 2 times 5 will give me 10. And that's it. So Jarrell says 15 would have been the input. If I do 15 times 2 plus 1, do I get 30? Yes. That's the beauty of this. That's the beauty of functions. That's the beauty of algebra. There's rules in place that you use to your advantage. Go ahead. We're going to take 10 minutes where you're going to work on those 2 other questions that are on the front page there, okay? You're going to follow the rules and you're going to find inputs and outputs. Throughout the course of a class, I'm kind of in real time doing assessments here and there. What did you get for this one, or explain what you did there, whether it's a right or wrong answer, and ask them to explain how they got there. And then if it was a right answer, you don't let them know until they're fully done explaining. We're dividing 32 and a half by 3. Show me where, this one right there? Yeah. Okay. So, remember when we looked at the first one, right? Kevin told us when I looked at these, when I had an output, right? I'm doing it backwards. So I
Right.
got to do the opposite, right?
So you're doing that 1 first.
Yes, remember we did the opposite of this and then the opposite of that, because that's how you undo stuff, right? Think about a present that's in a box, right? The last thing they put on was the wrapping paper. What's the first thing you take off? The wrapping paper, right? So when you're undoing it, you also go in reverse order.
Minus 1
Uh-huh.
will be 30. And then when you timing the 30,
And are we still timing it?
no, you
Remember-
minusing.
Well, what's the opposite of times?
Divide, division.
Yes. So I would
So I would say
subtract
2
1,
into
then
30.
divide it. Yes. How many 2s go into
Into
30?
30.
And that's how we got that one.
Right.
Okay.
15, yeah.
So let's apply that to this one right here. Okay. So the rule was times 3, then plus 2.5. Okay. So I'm undoing it. How am I going to undo this rule? What do I do first?
So it's just gonna be 32 if you minusing that 2.5. It'd be 30.
Is it?
Right.
30, right? Because we got, this is literally is 30 plus 2.5.
Right.
We're going to take off 2.5, and then it's just 30. Great.
So I'm timing just the 3.30, right?
Just the 30, correct.
The 30.
So, if I can, so our steps, our opposite steps are going to be minus 2.5, then, what's the opposite of times 3?
Division.
Dividing by 3, okay? And the steps you just showed us that you told me, this is what you came up with, this isn't me. You said I take the 32.5 and I subtract 2.5, and that gives me 30.
Right.
And
you
then,
gotta time that 3 or subtract the 3.
we're doing the
Division.
opposite.
Division of 3,
right.
yeah.
This is what we said, our opposite rule. Good.
Right.
So now it's 30, and we're dividing by 3. Forgive me for dropping that 0. We don't need it. So what's 30 divided by 3?
10.
10. Okay? Now just try this mentally. If I had 10 over here, I follow this rule, right? So try it. Put 10 times 3 is what?
That's 30.
Plus 2.5.
32.5.
And is that what the output says?
Yes.
And I think you got it. Okay?
you.
You're welcome. I almost think of it like I'm a guide, you know? Like, hey, if you want to go over there, that's what you'll find, but you have to do the walking yourself. I don't think any teacher can say, I've had a class where every student was at an identical place, had the same abilities, had the same gaps in learning. I still do have at least 5 or 6 different levels of learning in there, so there's a lot of strategies to deal with that. All right, guys, so let's just look at these real quick. See if we can do that in 3 minutes. All right? Can somebody give me their first 3 answers for the one where the rule was times 10, them plus 2? Kevin, give me those first 3, please.
22,
Says 22,
32,
32,
42.
42. Anybody notice any patterns here? Anybody notice any patterns? Oh, plus 10. Look at that. Very good thing to notice, Peter. 2, 3, 4, 22, 32, 42. Every time this went up 1, how much did this go up? 10. Interesting thing to notice. Remember, these functions, they're a rule that works all the way from 2 up to 2 billion and beyond, okay? They work for anything. So if I went up 2 numbers, how much would the output go up?
20.
It'd go up 20. If I went up 8, how much would the output go up? 80. Okay? Now what about this way? Somebody give me these 2 answers real quick.
79.
So 7 and 9. Okay. And Tesfa, can you explain to me, what do you think somebody did to start at 72 and end up at 7?
It subtracted 2. The operation will reverse. Then we'll divide by 10.
There you go. There you go. You do the opposite thing in the opposite order. I'm unwrapping a present, right? They took the ugly sweater and they put it in a box and then they wrapped it up in paper. Well, I'm getting my lovely sweater out. I take the paper off, then I undo the box, right? It's the opposite things in the opposite order. All right, and last one right there. 122. Good job, good job. All right, any questions on that? I think you got it pretty good. But we're gonna do the function game like we did in the last class. Except now we're gonna add in this new little wrinkle, okay? And our new little wrinkle is that the rule has 2 parts, right? It's gonna have 2 operations, just like all the ones we just did, all right? So the rule, I don't know it, but what you all know is that when I put in 5, I get out 12. My input is 5, my output will be 12, and I promise you, it took 2 operations to get there. It took 2 operations to turn my 5 into a 12. Remember, the way we play, you're not going to tell me what you think the rule is. You're going to tell me what you think a solution, an input and output pair that will work for the same rule I followed. Are we afraid to make mistakes?
No, I guess I'll be the first one.
All right, Tempest, what you got?
The input is 6
The input is 6,
and the output is 14.
and the output is 14. Very good. Don't say what you think the rule is. Say what you think a solution is. Kevin.
The input is 100.
Ooh. Yeah.
The
All right.
output is 102. 202.
The input was 100, and the output was 202. Great job. I'm starting to think I should have made a harder rule. Yes, Jarrell.
Input 75.
Okay.
Output 152.
152. Y'all are showing out. The CCR standards, I like them a lot. They're very interesting. They really help us know where to focus on and kind of gives you good direction, points you the right place where to go. Okay, this is an area that a lot of things are going to lead into. You know, you want to know what's going to give me the most bang for my buck. We're focused on functions with two operations and how to fill an input and output table following a rule. But we filled in with decimals and then money and then the underlying connections between them. And the farther you get into it, the more you realize division is a proportion, is a fraction, is a percent, is a decimal. And it's just, once it starts clicking, you start to see, you know what, I don't need to focus a whole lesson just on looking at 0.2 more as 20 cents. Hey, that's one of the things that you throw in when you're doing one of these larger picture things. And I find it liberating. Joseph, you look a little quizzical.
No, I just take it the simple one is I take 8, input 8. Its output one is 18.
And the output is 18. Yes. All right, let's take one more guess. Peter, yes.
The input is 10
The input is 10.
and the output 19. 22.
1922?
No, 10,
Just
20.
the 22?
Just
Okay.
22.
Yes. And Peter, what do you think my rule is? How did you turn your 10 into a 22?
Plus 12. I mean,
12?
excuse me, you said two operations, I'm sorry. 10 plus 2. Plus,
Well, I added a 10 and then
plus
a 2.
10 and plus 2. Or you could say 2 times 10 plus 2.
The way you got there, you
Yeah,
said was
2
2
times 10 plus 2.
Plus 2.
Right.
And how did we turn 8 into 18? That was probably 2
Plus
times
8.
8.
Right.
Plus 2.
Plus 2.
So my rule is, no matter what the input is, I'm going to do what?
You're going to add, you're going to
Did I add
multiply,
first?
Yeah,
I multiplied first.
and then add.
Times 2, then plus 2. You guys got it. Good job. I love sharing this joy of learning that I have, and I tell them all the time, take this home, spread it to someone else. It's contagious.